In addition to the Bermuda grass that came back with me from Mac Hodges Field in Georgia, I brought back a few things that need to be repaired on the P-26. Let's get started. Staring down the fuselage, you can see that everything is in pretty good order. I've just taken some time to do some basic repairs. The one thing that you'll note is these little pieces where the the covering has expanded, and that is unfortunately the price of admission these days. The covering just does not stick anymore, and there's nothing I can do about it other than strip it down and glass it, which you've seen me do. So for the time being, we're just going to roll with it, and maybe I can do some touch-ups with a covering iron. There's still a little bit of bubbling here. Maybe I can smooth that out, but not likely. Moving on to the front, there was a little bit of damage to the dummy radial, and it's kind of subtle. It's not a big deal, but it's just a little bit of rubbage here. Given the number of nose-overs that I experienced at CEF, this isn't really surprising. It's just a simple mount, one mount on the bottom, thick CA, and a clamp, and it's repaired. I did, however, notice that this seems to be missing. Not sure where that went, but it's gone. But I'm going to roll with it because it kind of tells a story, and the teething issues associated with this plane. Moving down this side of the fuselage, you've got the Venturi. This keeps breaking off, so I took pin vise and a drill bit and drilled a hole into this as well as this and put a piece of steel rod in between with thick CA. So now this isn't going to break off every time that I look at it. I did replace my spring here for the antenna, so given the number of times that's broken off, we're all set there. And that leads us to the next thing. If you recall from the maiden flight video, yeah, I had some issues with this thing, trying to sort out center of gravity and elevator authority, etc. So there's, shall we say, there were some on-the-field fixes that could have been a little bit better. So what I had done was effectively just use the digital trims to trim the elevator to the position that I wanted. I was kind of in a hurry, and I didn't really think through that. While that worked, I lost elevator control, meaning that I didn't have as much throw in my elevator, particularly in the up position. So for the servos, they were more or less like that at center. So I've done the right thing and gone back and mechanically centered everything to where my elevators were set when they were good. And that is just setting this top area at level. Obviously, I just moved this servo, so it's not exactly where it's supposed to be, but you get the idea. Rather than having a taper and having this centered, it's more like that, like where it's more level here and not necessarily centered. So that is the fix there. In addition to that, we had a little bit of a swap. What you can't see through the Velcro is an S. The S stands for stabilization. I know. I'm not one of those guys that is big on flight stabilization, except if you recall back a couple of builds, I built the old Great Plains GB Super Sportster, and I put an aura on that, and it made all the difference in the world. That airplane was so much of a handful in the turns, and it made it into a flyable ship. Now, having flown this airplane, it's a flyable ship, but it has some GB-like qualities to it. So learning that lesson, I did have the opportunity to mess around with this receiver in another airplane. And I've gone through and done a whole bunch of flying in my local flying field and really getting to know the technology and the ins and outs and setting it up and trying to familiarize myself with it. I'm not going to get into it here because there are plenty of YouTube videos out there. There's customer support from FrSky, so do your homework there. But I am using it to dial in or essentially dial out the nasty characteristics. Dial in good characteristics, dial out the nasty. What I like about the FrSky is that I feel like it helps take away some of my pilot deficiencies. And what I mean by that is I know that I'm not the world's best pilot. I'm really good at doing first flights, but I'm not really like a precision or a scale pilot in like really good sense. Okay, I know how to do basic maneuvers, but that's about it. I like to fly and build and build and fly and build and fly. I'm not one of those people that has one model that I just religiously fly all the time. So that being said, I have the stabilization unit in here. It's set up, ready to go, and I can dial it in however much I need. And what's nice about that as well is the way that I've got it set up on my radio. That's not a knob. It's on one of my functions or two of my function switches to dial it up or down. Is as I familiarize myself with the airplane and the airframe, I can take a couple of notches of stabilization out so that I can teach myself how to fly the plane without having to constantly repair it. Okay? That is my technical approach. Yeah, oh, the last thing that I really should point out, see that bubbling in the plastic? Yeah, that's from the sun. That's just from sitting in the Georgia sun. Yeah, that's not making me too thrilled, but there you go. All right, moving on to the wing. So the wing has a number of repairs. Well, both wings have a number of repairs that I've had to go through here. First and foremost, all of the solder joints held up just fine. So using the Starbright silver solder as well as flux, amazing stuff, amazing stuff. It just, where is it? Where is it? There it is. Stay bright, not Starbright. Stay bright. This stuff, that's your money for those mechanical joints. Absolutely amazing. Lets it flow really easy and good joints. All right. Moving on from there, we had issue with these tabs, these fiberglass G10 tabs. So they broke off. 50% of them broke off. So I thought that might be a problem. Turns out it's a problem that I should have addressed from the start. I had my suspicions on this, and I thought, oh, I'll just let it ride. I'll sort it out later. I knew better. I took the lazy way out. Happens to the best of us. So I'm going to address that today. I've got a fix, and let me show you what the fix looks like, and then I'll walk you through each step of the fix on these last two tabs. So the fix looks like this. It's a simple metal tab that is epoxied into this. So what you can't see is behind here, there is actually a bunch of fiberglass and epoxy material, and that makes for a very good base and substrate. It's exactly why down here I put in a couple of extra screws to hold this mount in place, because I knew that I would be using this for tension. And I didn't want to put stress on these holes. I wanted to put stress down here at the base. Make sense? So up here, what I do is first I cut off the tab. I cut off this extra tab because I wasn't using it anyway. I'm only using two on the bottom because that technically is scale. And so I am on the other side going to cut off the tabs and then create a slot in that spot where the tab is. How do I do that? Well, I'll show you. All right, so I'm going to do my best to try to walk you guys through this and then time lapse through all of the actual work so that you can understand the process. So the first thing I'm going to do is use my razor saw and cut the tabs off. I could break them off with like pliers and then sand it, clean it up. But I have found that a lot of the times these things will break irregularly. One of them broke fairly clean, but I'm not going to chance it. I'm just going to do it the clean, the right way. That's what I was afraid of. You have to get the right angle. I'm going to go this side first. All right, just for good measure, we're going to clean up with a little bit of a sand. Very nice, very nice. All right, so here's where the rubber meets the road. This is a coping saw. I don't need the coping saw itself. What I need is the blade. It is narrow and thin, and I just need to get that in somehow. So it turns out, because it's narrow and thin, if you've got a handle that holds a number 11 blade and you cut a segment of that out of a blade, a coping saw blade, you can get a little saw on a stick. So that is how I do this. I did do a little bit of a bevel here to get rid of burrs from cutting it. So I will say that this mark on my thumb is from when it popped out and I stabbed myself in the thumb. Make sure your tetanus shot is up to date. That's all I'm going to say. Yeah, you know when you've gotten past the G10, the fiberglass part, when you start getting a little bit gummy because you've hit the epoxy. The heat heats up, from the friction, it heats up the epoxy, and so it gets a little bit gummy in the blade. So depending on what you're trying to do, you may want to switch the blade from being a drag, essentially a drag. So this is a drag configuration, because look at the orientation of your teeth. So as you're pulling, you're doing the cutting, versus the other way where I flip the blade around, where you would be pushing and the push would be doing the cutting. So it depends on how you want to go. Play with that. Mileage may vary, but I've got 2 slots. So let me show you what's next. Okay, so the next thing we're going to do is prep our inserts, and for this you're going to need one of the Dubro. Specifically, you need the Dubro quick links. The reason why I say you need the Dubro ones, these black Dubro ones, is because it's a different quality of steel. You need the higher quality of spring steel for this particular application. Let me show you why. All right, so try this. Yeah, it just breaks right off. It's just broken. So that's why you want this kind, because the spring steel is actually going to bend instead of break. So what we have to do is essentially we're going to cut both of these off, and I'll show you how to remove the pin. So the first thing I'm going to do is going to cut the loose one off, and that's pretty easy to tell what to do. So I've got that cut off. So to remove this little pin here, all you have to do is first get a pair of pliers that's got a good grip on it. I've got these built-in grips. So grip it, and I do a little twist to loosen it up. It's nice and loose now, and then you start wiggling it. Because this is essentially a rivet on the back end, and you're just trying to break that through the spring steel because it's softer. And it does take some force, but eventually it just comes out and you've got a nice hole. It's just a touch bent from doing all that, but you can easily bend it back. And now I'm just going to cut this part off. Now I'm just going to clean up the ends. So now we've got these 2 pieces that are prepped and ready. Let's take them over and do some dry fitting. All right, so pretty straightforward. We're just trying to make sure that it goes in the slot and how far we want it to go in the slot. Right. So then you just make a bend. Doesn't have to be exactly 90 degrees. Just needs to be a bend to keep it from pulling out. Because that's all we're trying to do here. We're just trying to prevent this from pulling out of the slot. And then try to match that on the other side too. Oh, I have to test fit it first. I was about to bend it without test fitting it. You can kind of see on the back side, yeah. I can see a little bit on how much I need to bend. If I'm honest, I'd like that tucked in a little bit more. Let me see if I can make that happen. There we go, perfect. There we go. There we go. That'll be great. That'll look nice and sharp. All right, so the next step is to roughen up the metal. because we're going to apply epoxy. And remember, epoxy in this particular application will have no chemical adhesion. So we have to create mechanical adhesion. So we do that by increasing surface area on our piece by roughing it up. Okay? Just going to create a whole bunch of scratches in it. All right, so now I got to remember that the shorter one goes in the rear and the longer one goes in the front. Yep. So now we get to mix up a little bit of epoxy. So I'm using 30-minute epoxy, and that's pretty straightforward. You just do a little dab of each one. We don't need a whole lot here, okay? So I have a cup that I've previously used, and it's like half the size of a pea of each size, of each part, I'm sorry. So that way you have roughly a pea-sized amount. So I'm not even bothering to weigh this because it's going to be less than grams. So I am just stirring for, I'll sit here and I'll count up to 60 minutes, but I change directions, and essentially what I'm looking for is consistent viscosity. So each of the different parts has a different viscosity, one's thicker than the other, and as you mix them, it makes a different viscosity, and then it becomes white and marshmallowy, and I'm just looking for it to be consistent. All right, so I'm going to use my hemostat friend here, and since it has like a clamping force that I can put on and rotate it, manipulate, I'll use that. So I'm just going to take the end of my stick and apply some epoxy on both sides. You don't have to get too terribly heavy-handed with this. Just make sure that there's enough there that's going to fill your hole, or your slot rather. Put it in here, and then I'm going to slide it in place, rotate it, kind of move it around, let that flow, and let it go. I'm just going to leave that for a minute. This is a 30-minute working time, so we've got plenty of time for these two small pieces. I'm going to apply some more. In the slot, and we're set. Now, there's epoxy in that hole, and I got a little bit on the threads. That's important that I remove that. But first, what I'm going to do is I'm going to squeegee off the excess of my stick. And then in here, I am going to try to squeeze more into the space where I want it to be, and wipe out as I go. I'll squeegee that off. You can also use a paper towel to clean it off if you want. Whoop. See, I'm going to do the same thing. See how that wasn't entirely seated well in my slot? So now it is, and I can squeegee in some of that. All right, so as always with everything, when you do epoxy, have paper towels on hand, as well as your isopropyl alcohol. Okay, I'm using 91, but it doesn't have to be. You can get it by with 70%. So I have my epoxy stick. First, I'll clean that because I'm done with it. And now what I'm going to do, use a fresh part of the paper towel. I'm going to get it nice and sloppy wet a little bit. And I'm going to stick it in this hole up against my threads, and I'm going to turn this. First, I'm going to turn it out and count the number of turns. That's 1. That's 2. And that's 3. Now I'm going to change to a different part. I'll just fold this the other way, and then I'll screw this back in. 1. 2. 3. Okay. That way I know I got my threads clean of all of my epoxy, or at least as best as I can. You can do another inspection and check and see, and you can tell that I've moved my pieces. Now that I have my clean stick, I can go in and readjust, because I know there's a little bit of epoxy in there still. Note how this stuff is sliding around a lot easier now that I've got some lubrication on it from the epoxy, right? Again, keeping things clean so that I don't get epoxy where I don't want it to. All right. The last thing I'm going to do is try to wipe the ends of this. There we go. So you wipe the ends of it while you're pulling so that you get a nice seat on the back side. That way you're working that mechanical leverage with the bend as well as the epoxy. You're not relying just on that shear force of the epoxy, the mechanical nature of the epoxy. Okay, so we're gonna let that set for a little while and we'll come back. And we're back. And just to be clear, nice and dry. So our epoxy is set up and cured. And so we're gonna put things back together. We'll start with the fork end that gets screwed onto the threaded rod, like so. All right, so that's the mechanical one. And so these two are the new holes that might need to be slightly adjusted. Yep, that needs to go in maybe a turn or 2. All right, that's together. So now we have a repair that is done and set. And so now I can go ahead and do some additional cleanup, maybe some paint touch up if I can get this color matched pretty well. But overall, we just have to assemble the plane and readjust all of the clevises. As you can tell, it's not exactly an easy fix, but it is the right fix. Couldn't do it with a Dremel or an oscillating tool, so a hand tool was the tool of choice here. So the P-26 will be going back into the sky as soon as I find a break in the weather. We've had a series of thunderstorms and rain and rain and rain and rain and rain. My lawn is overgrown at this point because I haven't been able to mow. So I'm sure we're heading into the peak of summer where it's going to be so miserably hot that it never rains, which means hopefully that we'll have some flying weather, even though it will be hot and miserable. So look forward to the next update on this project, going over some of the additional flying characteristics with the stabilization. Do head over to dubro.com, use that code Josh10 at checkout so that you save a little bit of money, 10%. And until next time, guys, keep fixing your flying works of art.